Hello. Oh no. Major fail. Hello. Yeah. Hey guys, this was a major failure, actually. And you know what? The only thing I did wrong was I have plugged in my microphone to the headphone jack. Anyways, I mean, all the links we've shared are not working anymore, obviously. Sorry guys for starting a second time. This time I think stuff is working. Yeah, like I said before, I accidentally plugged in my microphone to the headphone jack. Yeah, I'm serious. It's that bad. Okay, anyways, thank you very much for joining. We have 13 visitors. I think we were at 35 in the last 5 minutes ago in the other stream. But, you know, yeah, things happen. Yeah, thanks for joining. It's a new live stream with the Pixel Pump. And actually, I'm super excited about the project. It finally is on CrowdSupply, and it already has passed the funding. And I could not be more, happy about that. It's super cool to get all your support for the project. It's amazing. So I thought another live stream would be a great opportunity to celebrate that. And also, it's if you have any questions regarding the Pixel Pump or any part of the project or something else, feel free to ask anytime. I will monitor the chat as good as I can. Yeah, as always, I have prepared a little intro, or actually it's the same intro then with the release video. But for you who have not seen it yet, I would like to start with the intro video, and then 3 minutes later or so we can start building an awesome PCB, and then I'm gonna share you or tell you what we're gonna build today. So we are having the Pixel Pump, the SMD magazines, and we are gonna build some cool stuff with it to demonstrate the capabilities. Okay, so have fun with the intro and see you in a minute. Welcome to the Pixel Pump, a Swiss Army knife desktop vacuum pump for PCB hand assembly with a whole variety of features. It comes with a foot pedal that enables hands-free operation by triggering the part pickup and release. The ergonomic handle is secured to the base with magnets and is connected by a tough but thin and lightweight silicone hose. Various modes and settings can be accessed through custom silicone buttons with dual RGB LEDs each. The Pixel Pump also comes with a set of 5 different nozzle sizes suitable for very small and also very large components. Its compact design allows it to become a permanent resident on your electronics bench. It's always ready for a quick repair, prototype or a small production run, just like a soldering iron. The Pixel Pump really shines with its accessories. A great way to store, organize and consume SMD parts is by using the SMD magazines. As opposed to assembling with tweezers, you're now having a vacuum tool allowing you to pick straight from the SMD tape. The magazines are custom designed injection molded SMD tape containers that come in packs of 8 pieces each. They are filled in from the front and can, for example, hold roughly 900 0603 passives. After marking the magazines with a standard 10mm label, you can finally get rid of those plastic bags. Up to 8 magazines can be clicked onto a magazine rail, which presents them in the perfect angle for picking and placing with the pixel pump. A spring-loaded lever in the front dynamically adjusts for tape thicknesses up to 9.5mm, making it a great storage solution for various components. An optional secondary foot pedal can be used for various things. It can, for example, send a keystroke via USB-C, which causes IBOM to advance to the next line without you even touching your mouse or keyboard. More info on that in the description. The Pixel Pump's hardware and software is open source. 2 separate expansion ports, 4 internal screw holes for custom PCBs, and a USB-C port for firmware updates make the Pixel Pump both hackable and serviceable. The Pixel Pump is designed and manufactured in my shop here in southern Germany. Thank you very much for your attention. I literally cannot wait to see what you build with it. Yeah, so we're having no audio, a choppy video. I think that's a really good start into a stream, right? Anyways, is the video now also choppy, or is it just the trailer? I sure hope things are fine now. Yeah, so anyways, thank you very much for joining. We have 36 people, which is really amazing. Hello guys, thank you very much for joining. I see so many familiar names. Hi Jason. Yeah, Bitloony, everybody's here. That's super cool. We have a real party here. Okay, well, okay, so the video is good. That's a really good sign. So let's maybe, I'm not sure if I've seen any questions so far, so let's just talk about the project of today. So we are building Brian Locke, who is also in the chat. Hi, Brian. This display driver. It's called the ESP32 Trinity. I'm sure most of you already know the board, or at least have seen it on Twitter or so. It's basically an ESP32 mounted to a compact board, which has all the necessary stuff to drive LED matrices. Yeah. We have 32 by 64, I believe, and also a 64 by 64, which it can also drive. And the cool thing that I think is that they have just a simple web USB, I think, interface to kind of flash new stuff onto the board without having to fiddle around with some IDE or so. So that's pretty cool. We'll see that later. Another thing, I have a new reflow oven, which I literally not have used a single. I just turned it on. I haven't reflowed any board, so I'm not even sure if we have the correct profile or whatever. But I can fall back to my old reflow oven if things are not working. So the main subject obviously is the Pixel Pump, and I think, or not I think, but this is a good opportunity to kind of talk about where and how one should use a Pixel Pump, right? So I see it as a prototyping device. So just in case we are Brian and want to, get this manufactured or so, we might want to just build 5 or 10 or maybe 20 or so for ourselves to test and maybe to give away or stuff like that before sending something to a fab. That would be a great use case. And also, I have recently bought an automated pick and place machine, and I already see a use case where I need the Pixel Pump. And that is, I'm not sure if I have an example here, but I have a few of the flat flex connectors, and they have the orange tab or the sticker on top of them. It's a shame I don't have them here. And they are pretty hard to source because every manufacturer who has automated machines needs the one with the clear tab so the vacuum nozzles can pick them up. But the thing is, with like those kinds of nozzles the pixel pump has, you can also use the ones that don't have the tab, and those are available because, you know, nobody's buying like the large reels for hand placing. So if I cannot source them, I just leave them away and don't let them place automatically with the machine, and just go ahead with the pixel pump and place a few by hand. I think that's also a great use case. Yeah, and also I think it's also a great project or a great tool to have because it's pretty compact and it doesn't have the overhead of the real estate you need for an automated machine. And I mean, unless you're doing like 100,000 of boards, or I mean not hundred thousands, but maybe hundreds or thousands or so. If you just need 10 or 20 or 50, or I built 35 pixel pumps just by using the pixel pump itself, and every pump has 3 PCBs, and I think it's a total of, I don't know, 100 components or so. And I did them by hand. And I mean, the obvious downside is if you don't have an automated machine, you cannot do something else while it's placing components. So that's, you know, that's with the hand tool, right? But other than that, I'm using it on a regular basis. And I'm a little biased, of course. I obviously like it. But yeah, I use it for all kinds of boards and stuff. And I want to demonstrate it today with a new board from Brian. The only thing is, Brian has a lot of 0402 components, which is not really a problem for me to place by hand and without a microscope. But I usually get really close to the board like that in order to see properly. So I have to see how that works out on the stream. Yeah, so I'd say, let me just peek into the chat if there are any questions. Guys, could you do me a favor, like with the dilemma here with my second stream, could you please just maybe tweet or answer my original tweet with the stream with the new link or so maybe people can find it a little bit easier? That would be awesome, very helpful. Thank you very much. So I'd say let's switch over to the second cam and start with stenciling, or you know, applying the solder paste, because that's obviously the first step. we had no audio. Oh my god. I was talking all the time. This stream it had started with the problem and it kind of continues. Okay, so let me get the short version of it. Sorry guys, I'm really sorry. Yeah, so what I prepared was I prepared the magazines, and what I did is Brian obviously, or like I said, provided all the components necessary for his boards, and those turned out to be, let's say, 1.5 or 1.75 of magazine rails, so like 14 or so. And what I did is I created the labels, so I have all the components in the magazines that I can pick and place them with the pixel pump. And I'll show that in detail just in a minute. What I also have is an iPad here, which is connected to my MacBook here. And it's just a remote desktop. So you usually have a workbench or so with a screen and just have IBOM there. And the cool thing about IBOM is it's basically an HTML representation of your board, listing all the components from top to bottom. And usually you have the board on the right side, but the iPad is so small and has so little screen real estate that I thought this is much better. But you could rearrange stuff in IBOM. It's pretty cool. You can have like the list on the left side and, you know, whatnot. So usually you would have to use your mouse as I'm doing right now, but then I have to let go all of my tools and whatever. So that's why the second foot pedal comes in handy of the pixel pump, because it sends the right keystroke for IBOM to advance to the next line. So basically it has all the necessary components listed in a table and is showing them also on the board. So I start with the first one, I place it with the pump and I don't press any key, just the second pedal, and it jumps to the next. Oh, the pixel pump is turned off. And then it jumps to the next line. And that's pretty cool because you can just have your pen and stuff in your hand without letting go and, you know, having to operate a keyboard or so. Let me just look into this chat. Yeah, Streamlabs OBS. Yeah, I'm using Streamlabs OBS right now, but it was all my fault. I plugged in the mic to the wrong port, and also I chose the wrong scene, which didn't have the audio source. So, you know, nothing to blame IBOM, nothing to blame Streamlabs about. So the pixel pump you are showing is the final version. Yes, this is the release candidate, if you will, for the pixel pump. That's kind of the final version with the label, CE marking, serial number. That's the final thing. And yeah, I'm not sure if, like, people said that the beta testers that received the pixel pump, most of them were surprised on how small the unit actually is. Let me just see if I have a Raspberry Pi or so. But I mean, you can see it. It fits in the palm of my hand, so it's really a compact unit, which is not taking up much space on your desk. And also, it's fairly heavy. It's like 500 grams, or pretty precisely 500 grams. By the way, the interactive bomb, yeah, that's the full name, correct. There's links in the description to Brian's project, and also to IBOM and, you know, CrowdSupply. By the way, I'm sure most of you know that already, but the pump is currently on CrowdSupply, and if you want to get a unit, you can do so. Okay, is there any question regarding something before we start picking and placing or so? I don't think so, right? I haven't seen anything. Yeah, it is fairly compact, and that was one of the main goals to build it, because I thought, as opposed to a traditional pick and place machine, you could just have it on your bench and don't have to put it away somewhere, or, you know, just have it next to your soldering station. Or that's what I do, and that's what the casing was designed for. Okay, let's go. Great. Let me just put on some gloves. I just don't like to touch the solder paste and rub my eyes or so. I'd rather rub them with the solder paste on the gloves. Gloves. So, it's so warm in here. I haven't even started the reflow oven. We're already at 26.4 degrees Celsius. It's crazy. There are some, just heads up, there are some needed parts in the BOM. Some do not place parts, or what do you mean, Brian? Yeah, so quick hint, the pump has 2 modes up here. There will be an extensive documentation coming in the next weeks, which explains all of that in detail. But you have 2 modes. You could either have it in lift mode, meaning as long as you press the pedal, the pump will operate. Or in drop mode is you just have it operate all the time, pick a part, and when you want to set it down, you hit the pedal to let it go, basically. I thought that's like a 50-50 thing, like people are preferring one mode over another. I'm preferring the lift mode, but there certainly are a few who prefer the drop mode. But let's get started, guys. So, coming back to iBomb, I have to take my mouse and go to the first line, and now I can, basically I don't need the mouse anymore. So if I hit the pedal, it goes to the next line. If I long press, it goes 1 line back. And so I can go through the entire thing. So it's starting with the ESP32, and I will not do that because I think it's going to be in my way when placing components next to it. I'll just go away from iBomb for a second because I think you have seen that, just to show how the placement actually works. So here's the thing. I always use tweezers with the pixel pump because there are situations where you need it. For example, if you start a new tape, you do not have it exposed that much. So usually, let me focus that. Usually the tape comes through the little slot above here, and if you pull it, it'll extend the tape and kind of release the parts. But if you start a new tape, you'll only have like this little tiny bit here, which is not enough to put it up here. That's why I just put it down and use tweezers to kind of extend it manually and pick it until it is long enough to get it through the slot here. The handpiece does not have a button, and that's on purpose because I think having a button on a handle where you want to place really tiny stuff is not really beneficial, because if you have to press or let go or so, you're always going to shake it just a little bit, and I think it's not very helpful. That's why the pixel pump is basically controlled with the foot pedal. So what you would typically do with the button is basically done with the foot pedal. So let's start. So we have the next component, which is, or the first component, which is an LDO. Oh wait, I think I have messed up the iBomb. Oh man. Yeah, I think I have to, like, usually I go ahead and sort the magazines as they come in iBomb, meaning I start from the left, which is the uppermost component. As I go down, I go to the right. It's not set up like that anymore. I think I accidentally hit some, some sorting or so. Let me just check that real quick. No. USB, LDO, yeah, and then a MOSFET. Yeah, perfect. Okay, so that's kind of how I have to start. So now I have my sorting. Usually I sort it based on the needle size, so I don't have to change needles all the time. So I place all the small components, then the medium-sized components, and then the large components. But I just, yeah, there's like 100 different ways you can do that. So let me grab the first component. Should I bring the camera in a little closer? Okay. So I grabbed the tape with the tweezers, just use the pump to get the part, and it's sticking there pretty good. And I see an iBomb where I have to place it. So in this case, I have to turn the part. I could turn the board, or what I also do is I just drop the part somewhere else, turn it with the needle, and pick it up again. That you can also do that. So I have 2 boards here, and I'll place 2 components. It's a panel of 2. Where is it here? I'm left-handed, but you can use the pump in like either side, doesn't matter. So I have placed the part. Okay, so now we have a situation where we cannot use the magazines because we have a tray here of components. But I mean, if you would not have a pixel pump, you would also have to dump them somewhere on the table and just use them from there. And also, don't take oops, sorry, that's enough. Don't take this stream as a reference for how quick or slow things are going. Usually, if I'm alone and at the desk, I am like placing a lot quicker than here on the stream. So usually I have one already assembled board as a reference next to me, so I can peek in and have the correct orientation of the parts, which I have to look right now. So the dot is on the left. This is also a great example. I just take the part, I put it here, I rotate it the right direction, pick it up again, and place it. That's it. All right, next part. We can have, you know what? I think I skipped a part. Yeah, definitely. Man, the stream last time was a lot smoother. I can say that. Let's just make these two boards as our initial starter and then get another one. Yeah, with Looney, I think that's the main problem. No. Okay, we have this one, we have, it's all fine. All right, another one with the wrong orientation, I guess. Those are the tricky ones, diodes. Okay. And is it that here? I think yes. Oh, I'm not sure with the orientation, to be honest. Yeah, I think this way. Turn it around. Some components are already loose in the tape. I sure hope I get those right here. This is one thing that's really hard to do on a stream where you just cannot move your face so near to the... Yeah, I think I did it the wrong way. Yeah, it's hard to see from, I have to be so far away from the stream, from the board. Have I missed any questions? Oh man. Yeah, but Looney, I think you are also known for, sitting there, not letting go before the project actually finished, right? Even if it takes 8 hours or so. Like I don't mean that like in a negative way. It's just I saw that. It's really cool. So I was watching a stream of yours, and I went to bed or so, or to work, and then I came back, and you were still like placing or doing the board, and I thought I was really like impressed. That was really cool. Okay. All right, so we have the diodes. You know what? I'll just continue with one of the two boards, otherwise it will just take too long for the first run. Yeah. So this one here, that's a great example. Let me just go over to the magazines again. So here's how do you, like you have the buttons here, and if you extended the tape long enough, you have the plastic tape which is long enough to go through the little slot here on the side, and then it comes up from the top, like so. And now it's actually starting to get interesting, because now you can pull the tape, which is a lot quicker. One thing, this component is exposed here. If you put that back in the drawer, it's likely that it's going to fall out. So what you can do, because it is spring loaded here, you can just push it back and it'll be covered again. And usually what you do is you just take scissors, and because it is clamped, you can easily just cut off the excess tape and store it. And that's, yeah, so nothing's gonna fall out here. As long as you don't extend like 10 centimeters, it's not gonna clamp. It's not gonna clamp down. It's clamping like 1.5 centimeters or so. Yes, I made the magazines. Wow, we have 43 viewers. That's really cool. Okay, so next component. And you know what? I think I got my pedals the wrong way around. Oh yeah, that's better. So let's take the button, which has to go here. Next one, Q1. Also one thing, usually, or you can do that how you like. Like I prefer having the value here, the size here, and the part number here, so you can look up the data sheet or so. But sometimes it's more practical to have just the reference designator here, like Q1 or R7 or so that you can have a quicker view to IBOM and know exactly what you need. So right now I have placed the HRO, which was the button, and SW1, which is the reference designator, and I'm luckily having HRO on the label here. But there are other cases where it's not so obvious, like this one here, UMH3N, is like in a different column on this row here. I could have prepared this a lot better with a little bit more time, but like I could have had like Q1 or R13, so you can place it quicker. Anyways, let's proceed. This one is another small tape which I just extend with the tweezers. Also a component with the pin 1 that I have to look up from my reference board here. That's a tricky one. I don't really see the numbers with the light here. Let me get one out. Wow, it's really small. It's a 6-pin, you know, you can't see that. You can show pin 1 on IBOM, yes, but you have to see it on the component as well. Like here, it is here, and I'm not sure where pin 1, you know, you usually do that with a microscope. Damn, how should I do that? Okay, I think I got it. Wow, it's in a different orientation. Brian, have you rotated the part? Yeah, it's... Okay, no problem. I got it, I think. I mean, it's correct in IBOM. It's just I have an early prototype from Brian, and I think it's maybe 1 or 2 revisions behind this one here, so no big deal. So now we have R13, which is not placed. Okay. So now comes the 0402 passives. Now it's gonna get interesting. I'm very fortunate that Brian has chosen, like, you have you can choose between the hand soldering pad and the machine solder pad, and the hand soldering pad is a little bit more forgiving with the placement. So we have the 10K resistors, which are 4 pieces. Okay. Do you want to have a different viewing angle or so? Just let me know. I can rearrange your camera anytime. Oh yeah, that's cool. The footprints are pretty big. The second part is going to be a lot easier. So we have the 100K. Let me just peek into the chat. Yeah, you can put them into a separate row, but I think it's only useful if it's more than like 3 or 4. But if it's only like 2 or 3 or maybe even 4, I think it's okay to have them on one go. So should we change the camera angle? Maybe let's put them up here. I think that's better, right? Okay. So we have 100K. That's the thing. I placed one of the 3 now, and I have to look which one it was. So, okay. That's cool. Next component is 1K, and then we're almost through with the first magazine rail. By the way, the magazine rails is, I think, also a pretty cool thing if you have different projects, because you can like switch projects pretty easily. And also, I always have one of the rails in front of me, and the other one is just somewhere else. And when I get to the parts, I just swap the rails so I don't have them, you know, occupying space here everywhere. So we have 1K 3 times. And by the way, at the beginning, it might be a little bit awkward to have the foot pedal, but over time, like after 2 or 3 boards, it kind of goes, oh, I misplaced them. It kind of turns into a natural extension of your arm or so. You don't even think about when you have to press it and when not. Yeah, I misplaced those. Okay. So 220 ohms, so I swapped the rail for the 220. Again, it's not long enough, so I used the tweezers, which is not a big deal. .1K. That's the USB resistor, I believe. Yes. Oh man, I have to be really careful not to place on the wrong board. You have missed diodes on one of them. Yeah, I switched over to just populate one of the boards. because it would take too long for the first go. I think people, you know, I might do another board after this one, and feel, you know, people can feel free to stay here. But I think if I do both at the same time, it's just gonna take too long. With my bombs, I'd need a dozen or more rails. Yeah. The thing is, like, if you have a board with, I don't know, 150 components, you certainly, yeah, need a lot more rails, I guess. But what I did here is Brian sent me a few standard components, like 100 nanofarads or yeah, like this one I just took out of my rail that I had for the pixel pump. I just use it for this one, and that's kind of the cool thing, because I have a tray, or you know, I put them in a drawer or something, and I accumulate them for the project, and the chances are getting greater and greater with every project that I already have a component that is already in a magazine and has components in it, which is pretty cool. All right, so we have those two. Let's go to the next, which is just a solder pad, I guess. This is also not a component we want to place. Now we have the LEDs, and that's going to be another tricky part based on, or in terms of the orientation. Let me just, yeah, I have no idea. There's a green arrow underneath. Do you have something? Is the green arrow? Yeah, let's just try them. Maybe I could do. Brian, do you know from the top of your head if it is affecting the function, or is it just not illuminating if I place them the wrong way around? I'll just do one of those this way and one that way, or not. Yeah, like I said, I'm happy to do another board after that if you want. But just to, you know, keep going and get done quickly with one board, I think it's better to just have one right now. All right, so those are a through hole. What function? Yeah. Okay. So, by the way, nozzle change. Yeah, the pump ships with a container like that, and you can close them and, you know, fixate them so they don't fall out, and you can also just take them apart. They are designed to have, if you wish, you can have them in individual ones, but what I do is I take one of each of them and just put them onto my working area, where I just grab and change them. I don't need some type of container to, you know, it's quicker to just have them here. And I just pull it out, and by the way, the handle has a relatively tough nylon lure lock tip, which means you can basically use every tip you get on, like if you need a different size or different shape, or they're different lengths, and so they're compatible with most of the tips you get from AliExpress or, you know, somewhere else. But I found those 5. I'm not, you know, I never ran into a situation where I needed a different nozzle. And also the longer ones, I think it's harder to place components because you have to be so far apart from the board. Yeah, okay, so I changed the nozzle because the fuse is a little bit bigger. Let's see. Yeah, that's cool. So we could do another board after that without talking so much, so it's more, we become more into a flow. I mean, usually if I'm not streaming, I obviously don't talk that much, and then it's gonna be a lot quicker. So this is a perfect example. Those are just not suitable for putting into the magazines because they are pretty high, and the bend radius is pretty pretty high, long, I don't know. And you could just have like 20 of those in the magazines, which is maybe not perfectly suitable. But technically, I think it's less than 9.5 millimeters, so you could load them into the magazine. Let me just grab a cap. The polarity is like that. How is the camera perspective? Is it cool, or you want to see something else? Yeah, Mauser sells those nozzles too. I mean, the Hakko pump also has nozzles which are compatible. There are a bunch of options. Okay, so 1 microfarad. We're almost done with placing SMD components. This is also a great way for tweezers. I usually pull the tape. It's a lot easier with the tweezers than with using fingernails. Now comes the last one. And then we have to reflow the board. And I'm super curious with the new reflow oven, how things are going to turn out. Like 0402 is basically the smallest, I guess, you want to go with the pump. I mean, you could have, I think you could do 0201 with this nozzle, but you certainly need a microscope. Like the pump is not the limiting factor here. Yeah, here. I'm suspecting there will be some tombstoning with the largish pads, but I'm not entirely sure. I will blame the reflow oven. Oh, there's 2 more here. 1. Okay. That's it. We're done. Let's give it a glance over. Oh no, the USB socket is missing. Or we didn't populate. And the ESP32, obviously. Okay, let's start with the USB. Not sure why I skipped that. Also, this one is a lot easier when you're at a proper bench. So, onto the ESP. Which one did I... This one is open, I guess. Only 22 minutes for that panel. Yeah, I mean, this goes a lot quicker if I would stop talking all the time. I think we should do a speed panel the next time or so. Let's just verify that things are working. And then we can do that. All right, let's see. I have to remove the components we have placed up here, or let's just leave them there. So, not sure how well you see that. But I think we have all the components. If we are lucky, we have the right orientation and don't blow things up. Let's go through the oven, shall we? Let me switch the camera. I will not make the sound mistake again. I have to add the mic in 1 second. I cannot copy a source, or can I? Cannot. What's with the diodes? Are missing? Yeah, well, I'm only considering the bottom. Yeah, I've only placed the bottom board. So, and I don't see the diodes missing here. Is that what you meant? If you've been assembling with normal tweezers, lift on trigger mode feels most natural. Yeah, I think so. I'm not sure. I think it might be, you know, some whatever PlayStation, Xbox kind of situation where, you know, if you just by coincidence started with the PlayStation, that's kind of your favorite or so. I'm not sure. All right. Let me rearrange stuff. Let's take a look at the Reflow oven. So, it has a bunch of like fans. I hope you can still hear me clear. It's probably also quite noisy, right? Could you just tell me how bad it is? I think it's okay. I mean, it is loud in here. So here's the thing. I have no clue how this is actually meant to be used because we have pre-installed modes that the previous owner has installed. That is the lead paste, the lead-free hand paste, and the lead-free print paste, whatever that means. I'll just go with the lead-free print paste because it kind of sounds the most appropriate. So we can go into the mode here and select M3. And I think that's it. I think we start here. Yeah, things are heating up. So I am not sure now if I have to enter the board into the chamber yet. Or so, I'm not sure, because look, let me just do it. So because I'm having, it's toggling between target and current temperatures. So if there's the minus here, it's the current temperature, and that's the target. It has 3 phases, which is preheat, I guess, soak or so, and reflow. I think it's okay to insert the board now because it's kind of preheating. Or what do you think? Can I zoom in here? Is that possible? Let me monitor the chat because I don't see it from here. Breaker is okay because I have installed the slow one. Yeah, you can reprogram, I think, 100 programs. Yeah, I think it should be in there for preheat. I thought it's gonna operate the tray on its own, but it's not doing that. You have to press the button, and when it's finished, I mean, I haven't reflown the board yet, but I just had let it do 1 cycle to test the breaker. When it's finished, it'll just beep, but it'll not automatically, you know, bring the board out again. And I'm also very grateful that this oven has a proper like ventilation system. I have connected it to my ventilation, you know, plumbing here. And the old one was a pain because I had to wrap it around in some cardboard or so to get most of the fumes. But now it's the low temp paste 217. Yeah, I also figured it's pretty low. I have the, like, I should have, honestly, I should have prepared that a little better with the oven, but I kind of just fixed it yesterday. I have the Loctite GC10. I also suspect that 210 is going to be, or 217 is going to be a bit low. I'm sure I could tune it, but I don't know how to properly. Yeah. What I can do is, I think when I press F, it's gonna just continue with reflowing and not cooling down. Maybe that helps, but let's just see. Yeah, the T962, yeah, I'm also going higher with that, but I'm not sure how accurate the temperatures are. The pre-owner of this one here has actually, you know, professionally measured and has done cycles and, you know, took the temperature at 5 different points and whatever. So I don't know. Yeah, I think it is a bit low. I agree with that. Let me grab the manual real quick, so maybe we could tune it on the fly. Yeah, like I said, I should have. I can change the temperatures here. It's actually not a big deal. Let me do that. Or should we not stop now? You know what? Let's. Yeah, let's abort. So we start with 170. Then we go to 200. I guess that's fine. What do you think? Shall we? I think the timing is okay. Let's go with, I don't know, 250, 260. I should look up the data sheet for the. Let's go with 260. What do you think? All right. Let's start again. It shouldn't be a huge difference now because it was not in a mode where it had a timer, so it's kind of just start or continuing to heat up. 240. Yes, it has thermocouples for profiling. Those are to the left and to the right here. I haven't got them, but I could probably somewhere. Yeah, I got a fire extinguisher. No worries. I'm well prepared in that regard. I'm not sure why it is honking all the time. Because this is blinking, which means it's running the cycle, and this is just the temperature view. So let's see if we can get a close-up of the boards. Oh yeah, I need a. I'm curious. And I'm a little scared if that's gonna turn out great or not. What kind of paste? I have the Loctite GC10, which is pretty expensive because as far as I know you can only get it, or Timon actually looked up or wanted to buy one, right? Was it you? I'm not sure, I saw it on Twitter. I thought it was a car horn. Yeah, it sounds like that. It kind of, like, the oven looks like it's burning right now because it's lighting up and turning off again. This is, by the way, this oven, it's like 100 kilograms. My dad, he's 74, and he picked up the pick and place and the oven with me, and was a tough ride. I didn't expect this oven to be that heavy. No longer Loctite, yeah. What is the new brand called? So right now we are at 200 degrees, which is, I think, the soak phase, right? Should we actually continue with placing boards or what? Oh no, it's only a couple of seconds. I'm not sure if this guy is gonna heat up to 260 degrees in like 25 seconds. Oh, it's counting to, no, it's counting down only once he reached it. Okay. So shall we get another close-up? I think it's done by the time I have the camera set up. Yeah, I opened up the oven because the circuit breaker was tripping when it started to heat. I thought it's some, maybe one of the halogen, how do you spell that in English or pronounce it in English? Lamps is broken or so. And I saw the inside, and the inside is basically like, I don't know, 5 millimeters thick steel sheet or frame. It's crazy. It takes a long time to heat up, to be honest. That's one of the downsides. But it might also be that I am actively sucking out air because I have connected my home, well, my shop, ventilation system, and I think it's meant to push out air once it's ready, not be, not having it remove the hot air while it is heating. But I don't want to have all of that fumes like in here. Let us know when it's QA time. Feel free to ask anytime. I'm watching the chat. If you have any questions, feel free to ask them. It is basically a QA stream while we are doing a board. Oh wow, this is not looking very good. You know what? Like, honestly, I have to shut down because I'm serious. You smell that? You don't smell it, obviously. But it is like the silk screen is kind of melting. Holy shit, let me put that back in. Okay, we were too hot, guys. Wow. It's not burning, it's bubbling. The board is boiling, like seriously. Yeah, the magazines I have here are 3D printed, but those are just the the prototypes. But I have the mold design, or not the mold design, but the finished parts ready for the manufacturer for the injection molding, guy. And I will have a meeting with him, I think next week, and then we'll start with making the molds. So I guess the board is. I haven't seen that before. Like I thought, you know, boiling off silkscreen. That's crazy. I never saw that before. Like how hot do you have to like be in order to, you know, have something like that? Look at how it bubbled here. Maybe that's why they had the temperature so low for the lead-free paste. Because, I don't know, maybe it has an offset or so. I mean, this one is toast. To be perfectly honest, oh, it's stuck. It's stuck to the tray. To be perfectly honest, I think the side we populated looks good. Yeah, it's starting to become a bit loony stream. Yeah, the bottom looks okay. Shall we try it? Oh man. Yeah, I figured, like, let me go back down to the 217. I'm also not sure what the honking is all about. Because, like, what is it trying to tell me? I have already pulled out the board. Yeah, it turns out to be as good as the T962, which is doing a better job considering this board here. The final product ready. Well, I mean, obviously the biggest step with that is getting CE certified. For those who don't know, I mean, CE is basically just a letter you sign as an individual. Even if you are a company, an individual has to sign it. And it only states that your product is compliant with all the regulatories that it has to comply with. So no one's telling you which ones your product has to meet. So the first thing, and that's one of the major steps actually, is to figure out which rules or whatever has, you know, do I have to follow with my product. And then, like the pixel pump, or you know, and also there are most of the rules that apply for the electronics that we build. Like, you know, we don't sell chainsaws or so. We sell like LED matrix drivers, which don't have a lot of current or, you know, dangerous parts where you could, you know, yeah, get injured or so. And most of the regulatories there do not require you to go to an official lab and get an official like certification from a lab. It certainly helps if you go to a proper lab and get a certification, that if you are having trouble with, you know, an agency or an individual or so, and they say, yeah, look, your project is kind of disturbing my radio signal or something like that, and if you have a proper certificate, you can show it to them, or in the worst case, show it to the court, and you're gonna have a lot better chances. Because you could actually sign the CE letter of declaration of conformity, which is the one thing that you have to sign. Let me turn that off here. That's a lot better. Like honestly, like this board, it doesn't look too bad. Like the bottom one. The upper one is completely done. But this one here looks kind of good. Let's see. How long are we into the stream actually? 1 hour and 30 minutes. Wow. Yeah, I think I had the wrong scene. I'm sorry, guys. Delete that. Okay, I think you can hear me now, right? Yeah, so what do you think? Do you have any open questions regarding the pixel pump? I mean, this stream is not going according to plan, obviously. I got a new reflow oven, which I never ever tried with the board. We had the sound problems in the beginning, but actually it's meant to basically demonstrate the pixel pump and the accessories. So if you have any questions, I think I missed a couple of them. If I just scroll up a little bit. Yeah, like I said, like the CE stuff, it was a bit of a pain. Fortunately, I had great input from the guys from Raspberry Pi. I had a meeting with them, or two actually. We were talking about the RP2040 and also about certification. They gave me a few tips, what I should do, and what is important and so on. Yeah, so CE is kind of really hard to give an advice. You can only kind of give, the big picture, because everyone has to kind of do the research for their specific projects, because there are so many regulatories. For example, the pixel pump has like 500 millibars of pressure and vacuum capable. It's capable of delivering that. If you had 500 or more, then you would fall into another regulatory. But only if the internal pressure volume is above, I can't remember the exact number, but is above, I don't know, 10 cubic centimeters or so, then you have to apply for that rule as well. So the first thing is to figure out what your project has to apply, or has to be conformed with or so. So it's not really a fun task. It's a lot more fun to develop the actual project than to do the CE. Yeah. There is a great article on SparkFun, I think, and also I read a book. It's called EMC Fast Pass. I think it's a free ebook, and it really gives a good impression, first impression with the CE and all, like FCC and whatnot. So if you're into making a project or a product, Google EMC Fast Pass. Could someone maybe post a link, or EMC Fast Pass? Yeah. It is in the crowdfunding phase right now. So you could basically head over to CrowdSupply and purchase a unit. The delivery date is January 23rd, I believe, and that is because I already have, or my dad is running the 3D printer farm, and he already is at serial number, I think 270 or so. So the 3D printing for 270 pumps is already complete, but I have to order the how you call them? Power bricks? I can't remember the name. What's wrong? And those have a lead time of, like, they come in December or so. And I cannot package the pumps because it is part of the packaging. So then there's, other other supply chain issues. So it's, and January 23rd is coming closer very quickly. But yeah, what I want to say is it's a pretty long lead time right now, but it's gonna go down from there, because I have ordered more components than I probably need pixel pumps for the campaign. I'm looking forward to, direct like shipping after January 23rd. So yes, it is a final product. It is developed. It has CE certificate. I have a couple of to-dos. One is the software is not yet 100% complete, especially the second foot pedal will get a lot more features. I will write the documentation because it's open source. You can develop plugins for it. You can put your own PCB into the pump. You could actually turn it into probably a solder paste dispenser, because it also is capable of delivering a pressure, not just a vacuum. You could add Wi-Fi, or you could add whatever you want. It has 2 expansion ports on the inside, which you can use to connect your own PCB. There's endless possibilities, but I still have a few to-dos, and they have to be done until January 22nd, 23rd. But yeah, the product is developed and it's finished. Like, I have printed, I have ordered PCBs. Yeah, that's the release candidate here. Did you see my sand question? You were asking. Yeah, yes, okay. So first of all, the rail is filled with sand. There's the opening here because it is a lot more heavy, and it is a lot more sturdy on your desk, because if you have small components and you bump against the desk or so, you don't want to have a device that is rocking around and spilling components. And the pump also, like the bottom piece, is a split part. That's 2 sections, and it's filled from the back here, down here. The cables are too short, so I cannot really get closer. So there's a bottom lid here, which covers the bottom. And the main reason why the bottom is split is the sand, and also because I need a smooth surface here to stick the label. And also I need, like, the upper side has grooves and screw holes and stuff like that, and I would have way too many overhangs with 3D printing. By the way, the pump is 100% support material free, so there's no post-production whatsoever, or post-processing actually, with the parts. Yes, and also it's also to give it more weight, because I personally, I just don't like products that are not heavy enough, because I think light products feel just a little flimsy. I don't know. And this is a solid unit, and I really like that it is half a kilo, even though it is just so small. Do you ship it with the sand? Yeah, it is. It's completely assembled. It's not something you have to assemble. It comes in a completely assembled state, which also includes the sand. How do you develop an open source project without giving all the secrets away? The thing is, the secrets, there are, I mean, actually, you say that, I'm not even sure if I yet have posted all the GitHub links into the campaign. I think I have to do that. I can't remember doing that. I will do that right after the stream. But I said from the beginning that I will publish the files or the GitHub repos once I have finished, or once the crowdfunding has started. But like when I think about that now, I think not a lot of people will actually want to build that on their own, because there are so many parts that I have sourced. You know, it was so painful to source, and also it's not going to be that much cheaper actually if you build it your own, I suspect, because if you purchase every part with a single unit, I'm not sure if you're that much cheaper. I mean, you can try it. It's open source. It's totally fine if you do that. But I'm really curious about how many people are actually doing it. The magazines is currently not open source. Like the version 1 is. You can, well, is it? Yeah, it's on Thingiverse, the version 1. But currently I don't have plans to open source the version 2. Well, or yeah, I'm not sure. I have to think about it. I mean, like, the thing is, if you don't open source it, like, you just buy one magazine, rip it apart, measure it, and you have, what, like 2 days worth of your time, and then you have the plans, right? So not open sourcing them is probably not gonna prevent people from, whatever, copying them. Yeah. Would you sell the file? No, I think I would rather just open source it. Like, you could have injection molded SMD magazines, or you could 3D print your own, I guess. Yeah, the Wii ones are okay. I have one here that Brian sent me with the components. This was the first actual idea for the magazine. And like the mechanism for the clamping mechanism hasn't really changed. It is the same thing. And they're also compatible with the current rail. You could still use it. But the main benefit, obviously, is that you have the spring-loaded mechanism in the front. Because like the one from Thingiverse, you had to choose the one with the right gap size. So if you had a, whatever, 2mm thick tape, you could have like one magazine for that tape, but you cannot have a different tape in it. Also, and that's one of the major downsides of the version 1, is if you only have a short remaining tape, which just has like 5 components left, it is super flimsy because it's not held in place here pretty good. And this version here has a spring force against the tape, so you will not even see a difference between having a full reel in there or a full magazine or just 5 components left. It is the same experience, and that was one of the things that annoyed me the most about the Wii ones, is that it could not hold the tape really firmly. Yeah, and that's the Wii 2 magazine. And the rail is also, like, the thing is, this is all pretty sturdy, right? So you can, if you click it in here, it is super sturdy. You can hold the entire rail on one magazine without any problem. And also it's not rocking around too much. It is held in place. And I had so many revisions figuring out which material I want to have down here. Like the main reason is, let me just grab an unpopulated rail here. So it's designed to have a certain gap. If I click the rail here, it's the magazine here, it's super loose. And the reason for that is, I wanted, like, you would have to fiddle around so much if that would be a tight fit, right? So how this works is, there's a silicone pad in the bottom, which just gives it enough back pressure, basically, to eliminate the slack. And that is yeah, and I went through so many materials like foam and EPDM and, you know, everything. And the problem was, like the biggest problem was that most of the materials, except this one here, if you would let the magazine in there for a week or two, it would not come back, like it would not like go to the original shape. So you will lose the tension. The magazine start flipping around. And with the silicone here, it's only pressing like you only have like a millimeter or 1.5 to press down, and it's the perfect material. It's hard to explain, but it's the perfect material. Like as far as I know. Can it demonstrate the suction toggle mode? Yes, sure. Absolutely. Let's go over to the pump. Let's talk about the features. So we have different modes. Let's go in a bit closer. So basically, you have the reverse mode, right? If you hit that, you have the pressure mode, and that's used for if you have sucked in some debris or solder paste. You could just take some cloth, go into reverse, hit the foot pedal, and it will create a relatively high pressure actually, which can, even if with the small nozzles, push out the remaining whatever is in there. And that's the mode for it. Because like if you imagine, if you take a cloth, let me just take one of those Kim wipes here. If you would not have a reverse mode and you would rub against the nozzle trying to clean the solder paste, you would always have something remaining in the tip, because you will always push it back in as you clean it. And when you do the cleaning with the reverse mode active, there's not a bit of solder paste that's going to remain in the needle. That's kind of the reverse mode and why that is, or that was integrated. So then we have like 2 presets for low and high, and that's basically what it says. You're going to have a low mode and a high mode. The low mode is kind of a little bit quieter, although I would not say that the pump is a loud unit. I think it's relatively quiet. But you can have 2 modes, because with 402s or so, you just don't need the full power. And I think you can squeeze out a little bit more lifetime. I mean, not that there's a shortage of lifetime, I guess. I have placed so many components with the first unit, which is still working flawlessly. But I think if you want to, like, I don't know, whatever, you could, it's just like you're not revving your car engine at full RPM all the time. It's just, yeah, I don't think it's great. Although to be honest, I think most of the time I just be in high mode. But what you can also do, and that's kind of the cool with the RGB interface, is you can adjust the modes. Meaning if you have a long press on low, you come into low adjustment mode. And now you can define what low actually is. If you, like, you can probably not read that, but there's decrease below the low and increase below the high word. And that's what it meant. Like if you hit decrease, I'm not sure if you can hear the pump. Let me go closer. You can preset or set a preset for low and high. And the reverse and trigger mode turn into save and cancel. If you hit cancel, nothing's going to be saved, and save obviously makes the other thing. Then the actual question, sorry that I come back so late to the question, you have drop and lift. And lift just means the pump is running as long as you hold the pedal. If I do that, if I press, let me show that on camera. If I take the pedal, let's put it here, and I press it, the pump's gonna run. And you're gonna have the part on the needle as long as you press the pedal. If you go to drop mode, it is now armed. If you just tap trigger or the pedal, it's gonna run even though you don't press it. And now you can pick up a part and you go to your PCB, and when you want to drop it, you just hit the pedal and the pump lets loose. And that's the 2 modes. It's basically the inverted mode or so, if you will. Oh, and the foot pedals, they have, just reminded me to talk about them as well. The secondary foot pedal is basically It's two same pedals. They have two connectors. They are mirrored, so one has to go to the pump and the other one is just the daisy chain to the second pedal. It doesn't matter which one you plug in to which port. It's just one has to go to the pump and the other two are for daisy chaining. How can you restore to factory defaults? Yeah, that's a good question because the answer is pretty cool. The pump is going to be, there's going to be a config mode that you can enter through a combination of the buttons, like hit long press and drop or so. And if you enter that, it's going to be enumerated as a USB mass storage, and it's going to expose a JSON config file. And in that config file, it has all the things you have set up in the menu. If you just delete it, then you will be restored to factory defaults with all the settings. I mean, it's not that many settings. You can choose the two presets for low and high, and you can set a display brightness. If you long press on lift, you come into display brightness mode. Same thing here, you can lower, or higher. Like, I think it's even better to see in the stream if they are a bit dimmer, and store it as you like them. And the JSON file will also be used for, you know, other configurations. You could set the function of the second pedal. Right now it's defaulting to, if you tap it, it's going to send, I think, Shift N to the browser or to the PC, which then causes IBOM to advance. If you want to have something different, like toggling between low and high, that's something you could set in the JSON file. So basically you have the pump connected to your PC all the time, I guess. And you, with a combination of button presses, it just enumerates as USB mass storage, so it's OS independent. You don't need some desktop software, some drivers, you need nothing. Yeah, that's how the JSON file works. And also, as there will be an SDK, you could have, okay, let's start different. The microcontroller is an RP2040, and the entire pump is written in MicroPython, like the entire thing, functionality. And the thing is, I'm having a GitHub repo that has a GitHub pipeline that compiles MicroPython with my firmware frozen into it. Meaning, it's not like your standard ESP32 where you use the Thonny or so to put your code into the device. It is stored into a different location on the flash and is compiled into bytecode. But you can still put your own MicroPython files on the device. And my plan is, I only made a quick prototype. I don't want to lean out the window too far. But the plan is that you could upload your own files, which then will be called by the Pixel Pump lifecycle, basically. And you can manipulate the state machine. So what I mean by that is, you could add an ESP32 with Wi-Fi or so, and have it, have it receive commands and manipulate whatever the pump does. And also then you could use the JSON file we talked about earlier and let the second foot pedal do something on your own PCB, because the Pixel Pump will then use the SDK you will get and just call some hook, so you could actually do something with the second pedal on your own. Yeah. Does it look like a drive via USB 3 connection? I'm not sure what you mean by that. Like right now, if you, I hope I can remember it correctly. I think if you go into drop mode and then long press lift, you're in bootloader mode, and now it enumerates as USB mass storage, just like the RP2040 does. It's their functionality. You can now also make a firmware update without any tool. It's just you have to drag and drop the file onto the flash, which now is just a USB stick. It'll reboot and have the new flash or new firmware. Yeah. Oh, and also, I mean, I said that in the intro video. The pump comes with a bunch of valves in it, and one of them is a relief valve. And I think that's a pretty important feature that I haven't seen in, you know, competing products. And the reason for it is, like, if you want to let go of a part, you don't want to have any remaining vacuum in the system, because you're gonna pull it off the, you know, your board again, or it's gonna stick to the nozzle. And I was thinking about, like, what it does is, you can probably hear it. Let me put it closer to the mic. If I hit the trigger and I let go, you hear a bunch of clicks. And that is the relief valve dumping pressure and then closing again. And what I thought about is, like, sometimes the nozzles are just a little bit magnetic, yeah. And sometimes it doesn't happen with paste, to be honest. If you have solder paste and you put a component there, and it doesn't come up. But sometimes it sticks to the nozzle, not because of a vacuum, but because of the nozzle is magnetic. And what I thought is, because of the plumbing the pixel pump has, I could just use the pressure for a few milliseconds and just, you know, put a small pressure on the tip, so the part probably gets ejected a little bit more or so. That's something that could be added through a software update. What I do for a living, I am a full stack web developer. I work 40 hours a week for a company in Germany. Can you rename it to Meat PNP? Why meat? Yeah, longer tube. I actually haven't ran into a problem with the tube being too short. I'm sure you could extend it a little bit. Let's talk about the tube. I found a really cool made in Germany silicone tube. It is super thin and extremely flexible. I mean, I hope you can, that's some hard to convey on camera, but it is really flexible. And it's also pretty stiff from the inside, meaning the vacuum is not, you know, pulling on it too much. So there's not so much elasticity, I guess, if that is even a word, that a longer hose might cause problems. I mean, if your hose is like 10 meters long, you're probably running into problems. It is 1 meter long right now. Yeah. You have been ignored. I'm sorry, that's not on purpose. The magazines you will sell are different. Yeah, they are different. That's the version 2 we were seeing today. And the one from 2019, I guess, is the version 1 that you're referring to. No, I'm not an electrical engineer. I have studied a bunch of things, but I haven't completed them. I have studied electrical engineering, I have studied mechanical engineering, and I also have studied computer science. But in all of those studies, I don't know, I just didn't enjoy being there, because it was either too slow paced or something I was not interested in or so, and I'm learning stuff on my own. It's working better for me. I'm a lot quicker learning on my own, and it just makes a lot more fun. No, these are not the injection molded ones. Unfortunately, I don't yet have injection molded prototypes. Yeah, so, I mean, I thought we would assemble more boards, to be honest. Should we assemble another one? Or should we just do it? I mean, or feel free to ask questions. I have to say the stream is a little bit rougher than the last one. I had such a great stream last time, but this time we had no audio, and, you know, the reflow oven was almost burning down the house and whatever. The Robbins tab is a flexible fabric label, as you would have it in a t-shirt. And it is clamped, so yeah. The rails have them, the foot pedals, and also the pump. Yeah, it hasn't. Yeah, I mean, I'm like, my actual first full-time job basically was being an iOS native app developer. I was studying mechanical engineering in Germany, and I was just hobbying around with the programming stuff. And I really, got interested in building apps for mobile phones. And yeah, it was a lot of fun. I made a cool app, which was a cycle alarm clock. I think I published it for free, and it had like 200,000 or 300,000 downloads. And I figured that I had so much fun that I just started looking for a job. I wanted to know if the reference of having that app is enough to get a job, and it worked. And I was working at a game shop in Germany, building apps. It was pretty cool. Yeah, I also like the fabric tags. Many years ago I saw a product which had those, and they immediately caught my attention. I thought, that's such a great contrast, like having a rigid product with a flexible fabric tag. And I remembered that when I was thinking about how to add a logo or something, and I just thought, let's try, and I really like it. It's really cool. And also, one benefit with having 3D printed objects is you have to have a really smooth surface in order to have a label sticking very well. And I did not want to have a smooth surface here. All the parts, it is designed so all the outside parts are basically printed on a textured sheet. So it is, it's a little bit rougher, in my mind it feels better. So a label would not stick here, and that's why those are pretty handy, because they are just clamped. They are not dependent on a smooth surface. I think I have a sample here of the actual clamping mechanism. Yeah, I do. So this is how it looks from the outside. And on the inside, there is a piece that clamps them together. Oh, you know what? I have an unpopulated pump here. By the way, this is how this is how I get this is how the pumps are actually manufactured, if you will. I have boxes. This contains all the parts for 1 pixel pump, if you want to peek inside. So this is the bottom, which we were talking about earlier. It has all the screw holes for the PCB, and those are going to be screwed together, filled with sand, and closed up in the front. The clamping mechanism is here. That's the side wall, and it has a bunch of features on the inside, and one of them is a slot here for the label to come through from the outside, and it's going to be clamped down with a bridge or clamp or whatever you call it. How much did you pay for the buttons? They were actually not that expensive. I found a company on Alibaba. They did silicone molds, and I was asking them for if they would do something like that, because my first thought was giving the pump proper keyboard switches, because I wanted to have a nice feeling for the switches, but it just I just thought it would be not be perfect. So I thought the silicone molds would be nice, and I wanted them not with the graphite inserts, but with a clicky button. If you wanna, let me put that near my mic. Can you hear that? That's a pretty clicky. It's really, I really like the feel of the button. long story short, I think the buttons were, like the prototype buttons were like a 400 euro mold, and you know, like 20 or 30, what did they cost, like 20 euros or so, and the production mold is like another 1200 euros, I think. Yeah, why Alibaba for the switches but not the magazines? I actually haven't gotten any quotes for the silicone molds, but I figured it would be a lot more expensive than in Alibaba, and this was the phase where I just did a prototype. Yeah. Bitloony, I have tweeted about that, and I can search the tweet after the stream because I had the exact numbers and the link to the company. Yeah. Maybe someone, yeah, I think I have to search it on my own. Yeah. Do the screws go into the plastic? Yes, there are no threaded inserts, and basically because I don't think it's a product where you would have to unscrew the screws like very often. It's not a, you know, battery lid or something like that. And I have proper Wirt screws which have a great grip. It's a Torx screw head. Those are like really good screws, and it is like every one of them is really satisfying to screw into the plastic. I have no like problem whatsoever with not having inserts. It's not primarily, or I mean, it would also be an overhead, right? Because I think one pump has like, I don't remember the exact number, but I think one pump has 80 screws or so. And imagine you had 80 threaded inserts. You had to insert, and you know, that's just not gonna happen. But I have like the electric screwdrivers. I only have 2 screw sizes, so I have 2 screwdrivers with the 2 bits, and those make things very easy. Have you thought about designing a metal frame? The thing is, people are asking me why I'm not doing injection molding for the pump itself. And I think it has many reasons to just remain 3D printing. First of all, I think it really depends on what product you do. If you're, for example, you know, if you are Sony and you're selling a television and you're selling a remote control that would be 3D printed, I think people would just throw it at you and say, look, what's the quality here? On the other hand, you have products like a Prusa printer, which has a lot of 3D printed parts, and it's not a big deal. Like, I mean, it's not even not a big deal. It's also I think a great benefit, because you could make your own replacement parts, you know, and it's also a lot better for me as a manufacturer to keep replacement stock, because every serial number, like, or let me start differently. I'm doing rolling updates all the time. Like, I have, I don't know, maybe 35 revisions among the 250 pixel pumps. Most of them are just internal differences, so I can assemble them a lot easier, quicker, or just be more efficient or so. Sometimes it is just a little aesthetic somewhere or so, and I always keep a track record of every serial number. So if you come back to me for a replacement part, I can always give you the STL files or the part, because it is tagged in GitHub with the version number that is tied to the serial number. That sounds complicated, but yeah. So if I have a new revision of some part, of some assembly or sub-assembly, I always keep track. I always have a change log, and I always exactly know what serial number has which revision of the parts. For example, like every pixel pump that is manufactured has a sheet like that. Can you read that? Here it says which printer has printed what part. But most important, I see the 3D printed revisions and also the PCB revisions, so I can track back the serial number to a certain part number and always, you know, make the appropriate spare part for a pump. And you could never do that with with sheet metal construction or injection molding or so. I mean, you're tied to the mold. And I mean, not technically. If you have like unlimited funds, of course you can do rolling updates all the time, but it's very inefficient. And with 3D printing, it's super efficient because you could just, I'm just publishing a new GitHub version to the print farm, and the next serial number will automatically get the updated part. And it's mostly when I'm assembling pumps that I see something on the inside, like I need, you know, the hole to be a bit bigger for some cable or so, and I just make it in Fusion 360, check it into GitHub, create a new tag, and the next pump that is coming out of the printer will have the new part. Hey Greg, is it in the morning? Yeah, it's exactly 12 p.m. or is it? Yeah, and here. How are you doing? Greg also has one of the very first Pixel pumps. Very early serial number. I just talked about the replacement parts and why it's not a metal frame, because I think it has so many benefits. It's also cheaper, obviously, because when you start with a project, you don't have the funds for injection molding, and injection molding for a complex part like that, I think you would probably need, I don't know, 5 or 6 molds at least. Yeah. And like said before, I think there are certain products that you could simply not do with 3D printing, like aesthetically, you know, extremely pleasing parts. Like imagine your car dashboard had a 3D printed, you know, whatever button cover or so. It would just not be appropriate, I guess. But I think this is a product where it's not, I mean, I personally think it looks pretty cool. And I don't think it, like the customer base, I guess, if you want to call it like that, is pretty similar to the ones who are buying a Prusa printer or so. And I have 12 Prusa printers, and I do not care, or I don't, you know, see it as a bad thing that it contains 3D printed parts. But I think if, for example, my wife would buy a new phone for whatever, how many euros, and it would be a 3D printed phone, it would just not feel right, I guess. If that's, you know what I mean. Hey Brian, have a great night. Thanks again for sending the parts. I'm sorry that we only have made one board so far. I wish I would have made more, but we were just doing questions, I guess, which is also okay. Yeah, so yeah, that was insane. I have to really make a new board tomorrow with the new oven, because that's not really good how that went before. Is there anything else you want to talk about, or did I miss a question or so? Feel free to repost a question. Yeah, please do that if I haven't answered it. I guess we would have to stick here for another 6 hours to meet Bitlooney's median stream length. Bye Bitlooney, have a great night. Thanks for joining. Do you have useful resources for reliable diagram? You mean like design-wise? Actually, the projects I do are basically consisting of, you know, the application demos of the manufacturer. So basically, the board is contains like a dozen subsections, and basically all of them are just application examples, more or less. Like for example, the main MCU or the MCU is the RP2040. I'm obviously following the hardware design guides
from Raspberry Pi. So therefore, I use the passives that they recommend, and you know, the flash and stuff. Same for like the buck converter or LDOs. Like if you stick to them, I think it's probably okay. But I'm not an electrical engineer. Like you know, the thing is with a project like the Pixel Pump, it has so many like subtasks, right? I made the electronics, I have written the software, I have made the mechanical design, I've made like the CE certificate stuff. I think I enjoy, you know, dancing on all those parties, if you want to say it like that, against being a complete expert of one of the topics. Like for example, I think I would be bored to death if I would have to do mechanical design like 24/7 or 40 hours a week. I love being involved in software, also design and electronics, but I'm not an, you know, expert level on all of those. Is there room in the handle to fit the inline air filter in there? Actually, no. The handle is as small as I could make it. It has the hose going through, but the filter is pretty small. It is really small, and this was by far the hardest part to source. I don't have room for it. Like the pen would have a different size. It would be thicker. I don't think it's bad here because you can see it. Like if it would be in the pen, you would not see it if it would be dirty or not. By the way, we could, I'm not sure if I demonstrated that, but you could easily take it apart like that. You can see through. It's a nylon, I think. No, what is it? PC or so, plastic. And a copper sintered filter. Focus a bit. Focus, please. Yeah. So you could just flush it out with alcohol if you want, let it dry, and put it back in. All of the parts for the Pixel Pump will be available as spares, because I think it's important to, like, the thing is, this is not a project, a one-time project that, you know, enters crowdfunding and gets forgotten. As I already passed the funding, I'm taking this as long as I can, or, you know, pushing it forward with new stuff and updates and whatever. I see this as a long-term project and not as something I'll forget after CrowdSupply or so. Not even close. I really want to, yeah, work on that for a long time. And therefore, I think it's very important to have a proper online shop with spare parts, like, you know, spare PCBs and spare 3D printed parts. You could obviously also 3D print them your own, but if you want to have the material and, I don't know, quality or time savings, you could just order them. You can also order spare like silicone hoses, and yeah, I think that's a very important thing. For example, with my print farm, I'm having like 10 Prusa Minis in the print farm right now doing pixel pumps and foot pedals and so. And I would never have chosen that printer if it did not have spare parts. Like the new 3D printer, like the Bamboo, that is like everybody's talking about, it is lacking like the spare parts. I mean, I'm sure they will come, and I think I got an email like a day ago or so. They were talking about spare parts, but it is not yet there. And I am changing like nozzles 5 times a week, and the hot end. I was at CNC Kitchen at Stefan's shop the other day looking at the Bamboo, and it's a really cool printer, but it's hard to get in there and clean the hot end, and it's proprietary and whatnot. So yeah, spare parts are really important. The rail is not going to be injection molded. At least I was thinking about doing an aluminum extrusion, and I guess that would probably be doable, but it's also a cool part. Like, I don't see any downside of that having, like, this being 3D printed. I think it's really cool. But yes, maybe to save time, or, you know, it all depends on, yeah, how many units are going to be sold, and that's so many decisions you just cannot make right now. But I would be totally open to rethink the 3D printed rails if there's a need or so. Yeah. Yeah, they have spares. That's right, and I think they have introduced something. Yeah. Yes, nozzle hot end related. Like I'm changing nozzles. I'm changing PTFE liners. I'm changing heat breaks all the time. And the Prusa Mini is such an open printer without an enclosure and stuff. You can really work on the printer. The Bamboo is enclosed. I don't need a printer that is enclosed because I don't print materials that require an enclosure. So therefore, I'm very happy with the Prusa Mini. Yeah, wow, we are 2 hours into the stream. If you want to see, like, we haven't really made that much PCBs. If you are interested in seeing the pump with more PCBs, I have another live stream recorded on the channel, which I did more PCBs. So if that's what you were here for, feel free to watch the other stream. I do like the Revo nozzle ecosystem. Yes, me too. But I can only speak for me, right? In my case, I print every part with 0.4 millimeters. I don't have a need for changing the nozzle size quickly. And also, switching to the Revo system would be a cost overhead that I just cannot justify, you know, because I don't have any benefit from it. It doesn't take long to change or to, yeah, you know, to change the nozzle on the Prusa Mini. And I think it takes maybe 3 minutes or so. If it would only take 10 seconds with the Revo system, like how often would I have to change a nozzle until the Revo system for every Prusa Mini pays off? You know what I mean? I think it's a cool product. Not that, don't get me wrong, it's a really cool thing. And I think if you are just having one 3D printer at home doing stuff with it and a lot of different stuff with it, I think it's a really cool system. Yeah, I really hope you found the stream interesting. Like I said, we didn't make too many PCBs, but I think we had a cool talk about features and the pump in general, and so feel free to ask more questions. Or should we do another board? I don't think so, right? We are already 2 hours into the stream. It's very unfortunate that we fried the board in the oven. Oh yeah, one thing about the magazines. There will be a tool to wind them up more quickly. That's why it has a hole in the back. The magazines will be attachable to some sort of device, which has some grip to the inside. I actually have a prototype here. Let me show that real quick. Where am I here? So this, you can have the magazine in here. You could put an SMD reel on that, go down with the tape, push it in, attach it to the clamping mechanism, which is not final, and then have this one to rotate. This way you can fill them up a lot quicker than by hand. But I just didn't think it would be, this tool is necessary for the project to start. I just want to get it out of the door, you know, get into crowdfunding and start the project, and this will be one of the next things that might come into the ecosystem. No, Timon, the mechanical files aren't, and actually that's a mistake. I wanted to publish them with the campaign, but I forgot, honestly. I said I will do that right after the stream. I will upload all the STL, or I'll just make the GitHub repo public, together with the code. But the code is already public, right? And the PCB is also. But I think I forgot the mechanical side of things. Yeah, sorry for coughing. The January it's not, no, injection molding will be a lot quicker. I'm hoping to have the injection molds finished in a month or two, and then they will start producing the magazines. But the problem is that I will have to order the meanwhile power supplies for the pump. I didn't do that because they are fairly expensive, and I just wanted to wait for the crowdfunding to, for the funds to do that, and they have a pretty long lead time. I think if I order now, it's like December, at the beginning of December, and we all know how accurate and precise those numbers are. I have a contact in Germany that has meanwhile power supplies for a few bucks more, but he can actually get them quicker. So if I run out of time, I will order them from him. But yeah, it's gonna take that long. And also, I still have to finish the design of the packaging, and I'm really looking forward to it because it really is a new hobby actually. Every stuff that I unpack is really, I really look at the packaging because it's so interesting to look and to see how that works and how people did it. And I think that's also going to take a lot of time to actually manufacture the packagings. But yes, mostly the reason for January 23rd is the holidays before that. So 23rd is like, we have holidays till 7th or so in Germany. And also like all the shipments and stuff are delayed, and because of Christmas and whatever. But the main reason is actually the power supplies, because they are pretty hard to source, and all the other components for the electronics, I sourced them in the course over the last year. So I have electronics for about 300 pixel pumps here on stock, and I believe there's no component missing, but I'm not 100% sure. I have most of them, let's say it like that. The pre-made 145 pixel pumps, they're actually not pre-made. They are just 3D printed. They have to be assembled. There have to be PCBs made for them, which I assemble my own with my new shiny Semtech 20-year-old pick and place machine. By the way, I really love it. I spend like 10 hours with the pick and place machine, and the software and documentation is a 10 out of 10. It is insane. I have already created my own parts. I have already used the vision system, and I already made a complete dry run. And after 10 hours, I mean, that's pretty cool. I have never ever used a pick and place machine before, like an automated one. You want to do a live teardown? I mean, sure. I got the screwdrivers here. Yeah, it's not 145. I think it's 260 or so. I think roughly 200, 220. I mean, we are at serial number 260, but I have made a few prototypes and changed them. So I think there's like 50 pumps or so that are not part of the production. Source your own supply. Well, I mean, technically sure, but like the price contains a power supply, and like the amperage is like, correct, and I think it's gonna be I think it would be an overhead for me, probably also for people to, you know, take stuff out of the scope of the project, basically. By the way, I get so many drop packets, like the warnings. Skipped frames. Is that OBS? Is my audio clear? Yeah. I think there's one component that I'm not equipped with 300, and that is I think the oscillator, the quartz. I only have like 150 or so of them because they were not. The thing is, audio clear videos. The thing is with the, like, if you get if you have a product that went into an EMC chamber, you don't want to, you know, change components all the time, because you're basically having to revisit the chamber. If you change basically every small component, you probably should do that. So swapping out components, sorry, that was, I think it was a bit loud. Swapping components is cool until, or, you know, choosing a different component that is available is cool until you have had like the EMC chamber. But I knew that, and I spent a fair bit of my savings on components because I knew that this is gonna happen. Like the shortage is gonna affect us all. Yeah, I'm not sure, the stream is not great today. Like, we had not a lot of luck with the audio and whatnot. Let me just scroll up if there's any question I have missed. Otherwise, guys, I think we should, or we could call it a day. It's really cool that so many of you have joined today to watch the stream. Thank you very much. I think we had a great time, even though there were a couple of things that didn't work out as planned. Yeah, 141% funded. That's so cool, actually. I really, yeah, that's really cool. Okay, guys, I think if there are no questions, I think I'm heading over to the bed as well. It's like 12 p.m. Yeah, okay, guys, thank you very much for joining. Yeah, but I think that's it for today. I'm really getting tired, and also I'm still having a bit of a cold, like for 2 weeks now or so. It's not COVID as far as the tests are concerned, but yeah, I don't know. And also we're 2 hours and 60 minutes into the stream. For everyone who is still here, who was looking for more PCB assembly, please head over to the last stream. I think I did like 10 PCBs, also a speed run, because usually I'm a lot quicker with the pump, but with the camera in the way and a completely unknown board, and you know, things are a bit slower. I think it's a huge improvement time-wise compared to like having tweezers and plastic bags. Like, the combination of the pump and the magazines is really, you know, making things quicker. And I'm really looking forward to having all your feedback once you get your hands on magazines and pumps and rails. Okay,